Hello students, we are going to start with the chapter Chemical Reactions and Equations, which is the first chapter of chemistry of class 10 NCERT CBSE syllabus. The term chemical reactions, what does it mean? Let us see first. So what is meant by a chemical reaction? Let us recollect back the knowledge which you have gained in class 9, that is the difference between physical change and chemical change. So as we know that physical change, no new substance is formed, whereas in a chemical change, a new substance is formed. Physical changes are reversible, chemical changes are irreversible. Physical changes are temporary, whereas chemical changes are permanent. No heat changes generally take place in a physical change, whereas chemical changes are associated with heat changes. So these are the basic differences between a physical change and chemical change. For example, melting of ice. Melting of ice is a physical change. Physical change. Why? Because if you melt ice, it becomes water. Again, water you can convert back to ice. Water, that is liquid form of H2O, and ice is the solid form. So as many number of times you can keep on interchanging ice into water, water into ice, means it is a reversible change. And it is a temporary change, means there will be no change in its constitution, its composition, and so we can say that no new substance is formed in a physical change. On the other hand, chemical change, a new substance is formed. To understand this, let us take an example of burning of magnesium ribbon. Burning of magnesium ribbon. So now let us take a look to a small video which supports this activity, the first activity of the first chapter, burning of magnesium ribbon.
A chemical change produces a new substance, and it can mean a change in color or odor, the appearance of bubbles, release of energy, or formation of a precipitate. Some examples of chemical changes are burning of wood, dissolving of salt in water, mixing acids and bases, and digesting food. Bottle. Our aim here is to carry out the reaction of burning magnesium in air and classifying it as a physical or chemical change. Materials required: magnesium ribbon, red litmus paper, a pair of tongs, and a Bunsen burner. Procedure: cut a piece of magnesium ribbon and hold it using a pair of tongs. Flame this ribbon in the Bunsen burner, collect the burnt ash in a watch glass and label it as magnesium oxide. This is a chemical reaction, as oxygen and magnesium come together to form magnesium oxide. Now, take red litmus paper and moisten it with distilled water. Place the moist red litmus paper over the watch glass so that it is in contact with the magnesium oxide. You can now see that the red litmus turns blue. From this, we can infer that magnesium oxide is basic in nature. This reaction shows a chemical change as the reactants, oxygen and magnesium combine together to form a new substance, that is, magnesium oxide. The formed magnesium oxide has different chemical composition which is different from both magnesium and oxygen.
So we have seen the burning of magnesium ribbon, and we got to see all these observations in this activity. First we saw that a dazzling white light was produced, then a white color, the magnesium ribbon, which is metallic, changes into white color powder, MgO, and this MgO, it turns red litmus paper to blue, which shows that it is basic in nature. So every activity which is given in the textbook is associated with certain observations, and you have to remember the observations even from exam point of view. Okay, now from this activity, what is the conclusion which we come to? We come to a conclusion that the burning of magnesium ribbon is a chemical change. Now why can we tell that it is a chemical change? What are the characteristics of the chemical change? Chemical change says that a new substance is formed. So here a new substance is formed, magnesium ribbon changes into magnesium oxide, and then this change is irreversible. Means you can't revert back magnesium oxide back to magnesium ribbon, and then it is a permanent change, and it is associated with heat changes. So yes, here heat changes are taking place. So from all these points we can say that the burning of magnesium ribbon is a chemical change. It means that whenever a chemical reaction or a chemical change takes place, there are certain observations which affirm that it is a chemical change. So let us now see what are these changes or what are these observations which one can see when a chemical reaction takes place. Let us see. So the observations are change in the color, change in the color may take place, or evolution of gas, or change in the state, or it may be change in temperature, or it may be formation of precipitates. So most of the times if a chemical reaction has taken place, then one of these observations can be easily seen. Like either the color may change or there may be evolution of gas. Now how do we come to know that the gas is evolved? Bubbles. So whenever through a liquid gas is getting evolved, there will be formation of bubbles. So we will see bubbles, then we will say that a chemical reaction has taken place because gas is evolved. Then change in the state, change in the temperature may take place, or formation of precipitates. Now with whatever resources were available with me, I am trying to show you a small activity which supports that when a chemical reaction takes place, there is a change in the color, or when a chemical reaction takes place, there is evolution of gas. So let us see these two things with the help of a small observation or a small activity which I have arranged for you. Okay, now here I have a red cabbage extract. I have taken out the juice of red cabbage and I am going to squeeze lemon into it. You can see the original color of red cabbage is violet. Okay, I'll try to show you as much as it is possible, children. There may be some limitations of this recording and all, so you try to concentrate. Okay, so here I have a red cabbage extract which is violet in color, and I am now squeezing some drops of lemon into it. And as you can see, children, the violet color has now changed to red color. You can see the red color. Okay, it may be a little bit difficult for you to. You can try this same thing at home. You can take a red cabbage extract, and then the juice is violet in color, and when you drop some few drops of lemon into it, the color changes to red. So I am trying to show. I don't know how much the visibility will be. Okay. Then the next one. Let us see evolution of gas. So here I have taken sodium bicarbonate, which is a white color powder, and now I am again going to drop some few drops of lemon juice, and you can see a lot of bubbles are coming out. There is an effervescence. We call this as an effervescence, just like how we open a soda bottle and we get to see lot of bubbles coming out. So here also, by putting the lemon juice into sodium bicarbonate, I am getting a lot of bubbles, that is effervescence. So this indicates that gas is evolved. So this is also a chemical change. So we have seen two observations which affirm that a chemical reaction has taken place. One is the change in the color and the other is evolution of gas. The third one, change in the state. Just now we saw like metallic magnesium, it changes to white color powder, magnesium oxide. Then change in temperature. This you can do at home. I can't show you from here because you need to touch the container in order to see the change in the temperature. So you can take small quantity of glucose and put it into water, stir it, touch the container, you will find that the temperature decreases, it becomes cool. So some of the chemical reactions may be associated with change in the temperature. And the last one is formation of precipitates. For seeing the formation of precipitate, now let us see a small video quickly which shows the reaction between aqueous solution of lead nitrate and aqueous solution of potassium iodide. Let us have a quick look. Okay students, so you have seen this activity wherein lead nitrate aqueous solution and potassium iodide aqueous solutions, they are mixed and you get a yellow color precipitates of lead iodide. Precipitate means when you are mixing two transparent solutions and you get out of that a solid substance, we call it as a precipitate. Clear? So we have seen all the observations which support that a chemical reaction has taken place. Now the next part of the chapter is something about equations. So let us go ahead now with this part of the chapter. So let me write the same equation again, burning of magnesium ribbon. So what it goes like, when magnesium ribbon is burnt, a dazzling white flame is produced and a white color substance, magnesium oxide, is formed. Okay, so this is a reaction which we saw just now. Magnesium ribbon is burnt. Burnt means it is reacting with oxygen and it is producing a white color substance, magnesium oxide. Now, if I want to write a chemical reaction in this way, think about how much time it is consuming, how much energy it is consuming. Scientists must have thought that there should be a simple way of writing a chemical reaction into some sort of mathematical statement or some sort of equation. So then it was like writing the expression in terms of words. For example, we can write this reaction in terms of magnesium plus oxygen gives magnesium oxide. We can call this expression as a word equation. The above what we have written, it is a equation. Now, again this takes a lot of time, lot of energy. So then again a simple way of expressing this reaction is to express the same reaction in terms of symbols of elements, or if there is a compound in the equation, then we are using the formula of the compound. For example, magnesium, it is indicated by Mg, and oxygen as O2, and magnesium oxide, the formula is MgO. So what is this? We can call this as a chemical equation. So what is a chemical equation? It is a representation of a chemical reaction in terms of symbol of elements and formula of the compound. What is a chemical equation? It is a representation of a chemical reaction in terms of symbols of elements and formula of compound. So this is the definition of a chemical equation. So children, we can call this as a chemical equation. Now if you have noticed, in this the number of all the atoms of the element are not same. Magnesium is 1 on both the sides, but oxygen on the left hand side, that is the reactant side, it is 2, and product side is 1. So we can say this chemical equation is a skeletal equation. Means it is just representing the skeleton of a chemical reaction. So we need to balance it. Balancing means making every element on both the sides equal in the number of atoms. Now what is the necessity for making these atoms on both the sides same? Because law of conservation of mass, it states that matter can neither be created nor it can be destroyed. So what does it mean? It means that total number of atoms of each type on both the sides of the reaction should be same. Means in a chemical reaction, none of the elements will get destroyed, neither any element will be formed. Means atom of every element will be same in number. This is the requirement according to the law of conservation of mass, and that is why we have to balance a chemical equation. So I will make all the terms equal. So it will be 2Mg plus O2 gives 2MgO, and this is what we call as a balanced chemical equation. Now let us understand the balancing of chemical reaction or chemical equations. This method is also known as hit and trial method. Meaning of hit and trial is we are just making trials to balance the atoms of elements on both the sides of a chemical equation. There are no specific rules, yes, but the basic rule is you have to balance elements other than hydrogen and oxygen in a chemical equation, and then you balance hydrogen and oxygen. So let us start with the first example. Fe solid plus H2O gas gives Fe3O4 solid plus hydrogen gas. Now children, the meaning of the terms which are written in the parenthesis, that is the brackets, it means it is this, these symbols show the stage of the substances which are taking part. Like iron is a solid, S stands for solid, G for gas, L for liquid, and AQ for aqueous solutions. Okay, so iron solid, when steam is passed over red hot iron, it gives Fe3O4, which is also known as magnetic oxide, or it is also known as ferrous or ferric oxide. As in this, Fe2 plus ions and Fe3 plus ions, both are present, ferrous ions and ferric ions, FeO and Fe2O3. both are present, and that is why it is known as ferric oxide, or it is also known as magnetic oxide. And hydrogen gas is also produced. Now let us see how we will balance this. So we make a list of the LHS side and the RHS side elements which are there. So left hand side we have Fe, and then we have hydrogen, we have oxygen. Right hand side again we have Fe, hydrogen, oxygen. Fe on the left hand side is single, one, whereas on the right hand side 3 atoms of iron are there. Hydrogen, 2 atoms, this side also 2. Oxygen, here it is 1, and oxygen on this side is 4. So according to the rule, we should balance elements other than oxygen and hydrogen. The element other than oxygen and hydrogen is iron. So we will balance iron. Here it is 3, so we multiply here by 3. Now whatever change we got here, we have to reflect it in the chemical equation. So we have to write 3 before Fe. We can't write 3 as a subscript, but we have to write it before the formula, that is as a coefficient. Now the next element, hydrogen, is already balanced. Oxygen is 1 here, oxygen is 4 here, so we multiply by 4 over here. Now whatever change is there, we have to put here, so it will become 4H2O. Again I am mentioning here that 4 can't be written as a subscript of oxygen. It is a wrong way to balance. The correct way is you have to write it as a coefficient. Then by changing the number of oxygen, the number of hydrogen gets changed. So hydrogen becomes 2 multiplied by 4. That is 8. So we made the change here. Now this whatever change is there, we will again make it here. So 2 4s are 8. Now this change we will again make in the equation, above equation. So we have to write here 4. Now let us check 3 on both the sides. Iron is 3, hydrogen 8, oxygen is 4. Same way here also, once we cross check, Fe is 3, this side also Fe is 3, hydrogen is 4 2s are 8, here also hydrogen is 4 2s are 8, here oxygen is 4, here also oxygen is 4. So the equation gets balanced in this way. Let us see one more example. Second example, we have barium chloride plus sodium sulfate gives barium sulfate plus NaCl. So now here we make a list, LHS and RHS, barium. Then we have chlorine, we have sodium, and SO4, we can write either sulfur, oxygen separately, or we can just observe on both the sides. SO4 is as SO4 on the right hand side also, so we can write it as a single species, SO4. Same way on the right hand side, barium, then chlorine, then sodium, and SO4. So barium is 1 on this side, on RHS also it is 1. Chlorine is 2 here, chlorine is 1 here, sodium is 2, this side sodium is 1, SO4 is 1 here, and SO4 is 1 here. So as we can observe, the number of chlorine is not equal, number of sodium is not equal. So in order to make the number of chlorine equal, we multiply here by 2. It becomes 2. So we will put a coefficient 2 over here. Now by changing chlorine, sodium also gets changed. So we have to make the change for sodium, and then again we will make, okay, now here sodium is already 2. So we need not make any change, it is already 2. Now let us check once, barium 1 and 1, chlorine 2, 2, sodium 2 and 2, SO4 is 1 and 1. So this becomes a balanced chemical equation. One more example we'll take, and then I will give you some few questions as homework. You can balance yourself. Now let us take the example of lead nitrate solid. We are heating it. A triangle sign on the arrow means heating. It becomes PbO, nitrogen dioxide gas, and O2 gas. So let us make a list. LHS, it is Pb, it is N. Now we cannot write NO3 as a single species because NO3 changes into NO2 over here. Okay, so that you have to take care of. Oxygen, and this side also we have, on the RHS side, we have Pb, we have nitrogen, and we have oxygen. So this side Pb is 1, this side also it is 1. This side nitrogen is 2, outside the bracket is 2. This side nitrogen is 1. This side oxygen is 3 multiplied by 2. This gets multiplied. So it is 6. And this side oxygen is present at 3 places in 3 different formula. So we write it separately. 1 plus 2 plus 2 in this way. Now if we see lead is already balanced, nitrogen is not balanced, and oxygen is also not balanced. Now according to the rule, we need to balance elements other than oxygen and hydrogen. So according to that rule, we should balance nitrogen first. But in this case, we can see here oxygen is here odd. 2 and 2, 4 and 1. This is an odd oxygen, odd number, and here it is an even number. So in such cases, first make the oxygen odd number even by multiplying this by the smallest number. So we multiply this by 2. So it will become even. Then it will become easy to balance. Okay. So before balancing nitrogen, I made the change here. Now whatever change I have made here, immediately I should make in the equation. So I write here 2 PbO. Now whatever change is here for balancing oxygen or making it even, then Pb got changed. So I multiply Pb by 2. So then this also will get multiplied by 2. So I will have to put a 2 here. Now by putting 2 here, nitrogen, oxygen, everything gets changed. So nitrogen, whatever number is, again we will multiply it by 2, it becomes 4. Now this change I have to make here, and then this change I have to make in the equation. Same way for oxygen, it was earlier 3 2s are 6, now 6 2s are 12. So now I have to make a change over here. Now when I put 4 in front of nitrogen, the second oxygen got changed. The first one we have already changed, second it became multiplied by 4, so it becomes 8 and 2 as it is. So let us see, 6 2s is 12, this is 8 plus 2 10, 10 plus 2 is 12. It means that now it is balanced. Lead is 2 on both the sides, nitrogen 4 and 4, oxygen 12 and 12. So it has become balanced now. So children, we have taken 2-3 examples of balancing of equations. I hope so that you have understood how to balance the equations, and soon after sending this video, I will be sending you some 8 to 10 examples of balancing the equations. You balance it in this same manner. If you have any doubts, you can ask me, and in order to make proper equations, proper formula, you have to learn the valencies. You have to learn the list of cations and anions which we have done in class 9. That is very, very essential. That will really help you to make correct equations, the correct formula, and if your formula is correct, then only you can make proper equations. Getting it? So, the remaining part of the homework and all,